You want a philosophical discussion.
More or less, yes. And at times it may or may not turn into a therapy session, but we'll have to see how that works.
Great. Good.
So I guess I'll start with, what do you think makes a good engineer?
Whoa.
Yeah.
That's a very interesting question. I guess the first thing that comes to mind is an obvious criteria, which is you've got to be interested in things. You've got to be interested in what makes the world work, I guess. You know, back when I was growing up, those folks who went into engineering were either spending time working on cars, or as amateur radio operators, if they're going into electrical engineering. They had already established some kind of a serious interest and joy in building things. Now, engineering today is pretty broadly defined and doesn't always involve building things. And when I say building things, I'm talking about physical things. So, you know, a software engineer, yeah, he's creating something, but he's really not building something. I don't know, sitting in front of a computer screen and writing code isn't the kind of joyful experience that I think engineering can afford people. Yet it seems to be a very, very popular path people are taking today.
Why do you think that is? What do you think has changed over the years?
Well, I think, you know, a lot of it has to do with what kids read in the news, if they read any news or hear about it. For example, when I was in high school, we had the Apollo program, right? Sputnik went up. There was all sorts of chest pounding and, you know, beating the drums that we really had to advance science and engineering. And the Apollo program was dramatic and it was romantic, and everyone wanted a piece of it. And, you know, it was for the most part building things. I mean, a lot of software for sure, but building things. You know, amateur radio at that time was pretty much, you had to build your stuff. So that by the time you got into college, you had already had a fair amount of experience building stuff. You know, whether, you know, you grew up on a farm and you built stuff that was necessary for farming, or worked on tractors or whatever, or you were, you know, much more urban and you were an amateur radio operator and you built a lot of electronic stuff, which also, by the way, included a lot of mechanical components. Today, you know, what is it that you hear about when you, you know, when you look at job listings, for example? You know, lots of opportunities for coders, software. I'm reluctant to use the term software engineer, but yeah, software engineer. You know, there's a big demand for them because a lot of products today are built on software, and the hardware is built somewhere else, right? A lot of the hardware today is built over in China or India, and unless you're in certain disciplines, like bridge design, where the hardware is built here. So, you know, it depends upon what kids grow up with, you know, as to what they think is going to be the path to glory.
So to that point, I guess, and I remember you mentioned this in the other podcast that I heard you on. You said that when you were younger, you spent a lot of time tinkering with stuff, whether it was like an engine or whether it was like electronics and such. And I remember you mentioned that the stuff that we have these days is not very, I guess, conducive to such tinkering. The engines we have these days, the electronics we have, they're much more difficult to mess around with. How do we compensate for that lack of, I guess, opportunity when it comes to those kind of things? Do those kind of skills just fall out of what's common knowledge, and do we just have new and normal skills? Or like, so as opposed to like being good with your hands, you're good with programming? Is that where we're going, and or what's happening there?
Well, I don't think it's all programming.
Well, yeah.
Yes, you're right. The opportunities for tinkering that we used to have no longer exist. You can't really fix your LCD TV set. You can't get inside your car engine. I mean, you could if you had all the right tools and you had a lift and you also knew something about electronics, because the car today is all electronic. But there are opportunities in a much more disciplined form, I think. For example, a lot of high schools are engaged in what is it? The contest that it's almost universal now.
Hyperloop?
They get a kit of stuff to build things with.
Arduino?
No, not the
Like
Arduino.
Things?
It's kind of a national contest that
well, we don't have those over here then, I guess.
Well,
maybe we do it.
There are such things,
sure.
Contests. And in college there are, for example, electric vehicle racing teams, yes, or solar cars, right? Mm-hmm. So they aren't as accessible to the high school student as my father's Jeep was to me, or that amateur radio stuff was to me. So they got to sort of search it out. And I guess they have to be inspired more by what they learn in high school or even grade school. Is the science class that they're taking exposing them to getting their hands dirty, which is a good way, I think, of describing it, or are they just clacking on a keyboard? Simulations are fine, but that doesn't really tell you how it's put together.
Right. So what was your experience like then, as because you're saying that obviously teaching and education is a big part of it. So what was your experience like as a elementary school student or a high school student? How would you describe, what was the turning point, if you can think of one, or was it just a gradual entry into this?
I guess it was, I can't say that I was inspired by any particular science course I took in grade school or high school. In fact, I went to a high school that was very blue collar. I lived in a blue collar neighborhood, blue collar town in New Jersey. We didn't even have, in my senior year, we didn't even have a calculus class, which today is unheard of, but back then that wasn't so uncommon. So before I came to MIT, in the summer of my senior year in high school, I went to the local university and took 2 calculus classes at night because I was petrified about coming to MIT and not making it. So I didn't get inspired by anything in high school, except because I was already interested in that stuff and knew things about general science, not biology. Biology was my nemesis, but general science, I managed to give a few lectures in the high school science class, and we had general science, right?
Hmm.
Um, and I remember, here's something I remember very, very vividly, and I was kind of astonished. One of the little experiments that we had to do in the science class was to string up a couple of pulleys that had multiple wheels on them, so you could demonstrate mechanical advantage, right? So, and so the first thing that the students had to do was to thread these pulleys, and I was amazed at how many students had no idea how to run the string through the pulleys in a way that was correct, up here, down there,
Right.
through the next one, then the next one, and the next one. I was just astonished. I'm not sure that's the case today, but I still think that there's probably a great deal of ignorance about mechanical things today because there isn't as much exposure to it available.
I think it might even be worse now than it was before, to be honest with you. If we were to go down to like the high school level, just because of like, I mean, I think about people in my family or in my immediate surroundings, like extended family and such. There's very little knowledge of mechanical stuff because there's no reason for it. I think there's more like, I guess in the average person's life, there's a shift away from mechanical things. Everything is electrical, and if you don't know how to fix it, you take it to the repair guy down the street.
Yeah.
So there's no reason to thread a pulley or to, you'll be surprised. There's people that are like 18, 19 years old that I know that don't know which way to turn a screwdriver when they want to tighten the screw. And I mean, it's something as simple as righty tighty, lefty loosey. Like they've just never heard of that, right? So I mean, like we can think of it in terms of torque and in terms of moments, and we we won't forget. But for them, it's like they can't even learn that. So I mean, I don't know. There's certainly a charm associated with mechanical things, and a fascination that if you look at it very carefully, you can't help but notice the amount of detail, like a well put together watch, for instance. Is absolutely fascinating to look at, I think.
Yeah. Yeah.
So,
and here's another thing. How many kids today have their father's tool shop in the basement?
very few,
Very
if
few.
any at all.
Yeah.
Yeah. I mean, myself included. My dad's just not into that kind of stuff. So I naturally, from when I was a child, I wasn't. But then on the other hand, my mom's kind of really into that stuff. So she would always be getting me to do things around the house and do this and that. And so now I have like a fairly decent set of tools, but still it's nothing to the level of what you see and like when you watch these movies and like, or like you watch TV shows and these guys have like these tool shops and they're working on cars and it's like this old stuff from like the 60s, 70s and 80s and so on. It's just not that same kind of thing anymore, I guess. So,
I always give my grandkids,
Sorry.
I give my grandkids tools for presents.
Do they enjoy them?
Yeah, most of them do.
Yeah. Well, do they actually do anything useful for them?
Yeah, and whenever they're here, I take them down into the cellar,
right,
and try to figure out something that we can do together.
Right.
Because I think it's a skill that they should have. Right.
Mm-hmm.
They should know how to saw a piece of wood in half. They should know how to turn a screwdriver.
Yes.
They should know, that nuts and bolts come in different sizes.
Right.
And yeah. Anyway.
Well, how many people agree with that? That do you think? Like, I mean, as far as in your circle that like, because I mean, I'm like, I think it goes without saying that you're from a different time when you say these kind of things. I'm not saying what you're saying is not relevant. What I'm saying is these things are not valued so much anymore, and they're not necessarily taught at the to the average person anymore. So, is there any pushback when you say those kind of things?
Well, I guess I don't say those kind of things very often to people who wouldn't appreciate them.
Makes sense. Yep.
But if I in my 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 cohort, all right, grew up pretty much as I did, right? I mean, my faculty colleagues who are my age pretty much had the same attitude, right? Younger faculty, I don't think, I don't think they are as interested in that. They've got other things that they are doing, right? I mean, you know, here's a description of the discrepancy between what I was doing when I was a young faculty member and what a young faculty member today is doing in the lab. When I was building something, we would build it on an aluminum chassis. It would be point-to-point wiring at the beginning. When we started using PC boards, we would get the raw board, which was just, you know, the fiberglass board with a layer of copper on it.
Right.
And we would put the pattern on with black tape of varying widths, mm-hmm. and draw out the circuit. And then we would etch it in a bath and make the PC, but then we'd have to drill it and make the PC board, right? The density wasn't very great, mm-hmm. on those boards, mm-hmm. as you can imagine.
Yep.
And the components were fairly large. Today, as you well know, because you've built stuff, mm-hmm. The process is much different.
Yes.
It's not nearly as hands-on until you get, of course, to the high power stuff where you've got to wire things together that can't be put on a PC board. Although it's amazing what you can put on a PC board today, yes, in terms absolutely. Of, you know, components that have power handling capability that's in the kilowatts on a PC board. So the environment is different. And, you know, if you're not forced to use a screwdriver, you're never going to learn how to use a screwdriver.
Right. Yeah, I guess that's what it comes down to, right? And so that's like the shifting norm or the sort of standard of what's happening these days versus what was happening before. So you talked about this before when you responded to my question in the lecture that you gave a few months back, and you were talking about this idea of what faculty members are like today and what they were like in your time, and you've just alluded to that right now as well, about the differences between what you did as a faculty member when you were active and doing all these kind of things versus what they're doing now. I mean, I guess I could ask about MIT because that's where you've been there for essentially a lifetime, right? And yeah. How has it been overall? I mean, as far as your time there, first as an undergraduate student, and then developing as a faculty, and then your experiences, I guess, first as an graduate student, young faculty member, and then what you see today. First of all, I guess, what was your experience like? And then how do you think the overall institution has evolved since then, if it's evolved at all?
Well, it's evolved a lot.
Okay.
I wouldn't trade my experience from the moment I arrived at MIT until today, even. I wouldn't trade it for anything else. There have been times when I've been unhappy, as everybody is. There are times when I've been disappointed in either myself or somebody else. But those were rare compared to the enjoyment of the job. And I loved my undergraduate time at MIT. I thought it was fabulous. I've got a lot of good friends today who were my classmates as an undergraduate or a graduate student. You know, things evolve. I don't think that, you know, the faculty situation when I joined the faculty was better than it is today for a young faculty member. It's different. In some respects, it's better today. There's a greater sensitivity to the need for supporting faculty financially and emotionally. There's a much greater degree of competition today than there was when I joined the faculty, because today there are, you know, qualified people coming out of doctoral programs all over the country. When I graduated, you know, there were just a few schools that were rated comparably with MIT, you know, Stanford and Berkeley. And also at the time I graduated, MIT, at least in my department, you know, used to hire quite a few of its own graduates. So is it different? Yeah, it's different. Is it better than when I was joining the faculty? No, I don't think it's better. Is it worse? No. I think that the life of a faculty member in many respects hasn't changed. It's a more than full-time job. You've got to be careful to not let your love of the job ruin your family life. You know, I tell junior faculty members that the first thing you've got to remember is that if you've got kids, they deserve some of your time, and they're going to grow up faster than you think. So spend some time with them.
So what do you think makes a good faculty member or researcher, I guess? Researcher, teacher, faculty member. If you want to be a well-rounded faculty member, what would you, if you were to look for somebody, what would you say makes them competent, good, character, whatever you might say?
Well, I guess there's two principal requirements. Number one, they better be proficient in their field. And number two, they better enjoy teaching and value their students. I don't think there's any other real criteria that dominates those two.
Right. So you said just now as well, I guess, and you said, I heard it earlier as well, you said that there's much more competition in the field now, and there are way more, I guess, we're churning out PhDs at a higher, it feels like almost at like an accelerated rate these days relative to the past.
Yeah.
So then how does one stand out, I guess, as a PhD if you want to, let's say, be a faculty member, if you want to do these kind of things? Because one thing we're seeing is, and this will, I mean, we'll discuss this issue later, but we're seeing an increase in the amount of research that's being put out, I guess, yearly, if we just take like a fixed interval. So I would imagine I mean, from what I understand, I think you also mentioned this in a previous talk or something. You said that, I think you said, you probably said it as a joke, but you might have been serious. You said that some of these conferences have become too big relative to what they were when you started. So then how does one stand out, I guess, as a researcher or as a PhD, or getting into a place where you want to be a faculty or something like that when there's so much competition?
Yeah. I don't know that there's a simple answer to that, but you're right. I bemoan the size of the conferences because it doesn't allow for the collegiality that used to prevail at conferences in the past. And it's reflected in the size of the transactions. I mean, let's just consider our own society, okay? The Power Electronics Society. I mean, the number of papers that get published every month in the IEEE Pell's transactions is enormous. And the number of submissions is even greater. And part of the problem is that there are multiple parts of the problem. First of all, a lot of universities, especially foreign universities, have distorted metrics about what constitutes a successful researcher. And those metrics often rely on these measures of how many times your paper has been cited and things like that. I don't know, but I forget what the name of the thing is.
It's like an H index, I think it's called, isn't it? Something like that.
The H index, and there's another one.
There's a couple of others, yeah, something like that.
Yeah, which never existed, by the way, when I only heard of those indices probably 10 years ago or so. I've never paid any attention to them, but when foreign universities that are churning out lots and lots of students, and here I'm talking about the Indian universities, the Chinese universities in particular, that are using these indices as a measure of whether somebody is where you are in the hierarchy. It becomes meaningless, and then it forces people to publish papers or to try to publish papers that are worthless. And a lot of them get through the review process because if you're given 10 papers to review, it's a bitch.
Yeah.
I mean, I'm not proud of this because I think I don't think it's responsive to the needs of our profession, but I really dislike reviewing papers. It's a hard job.
Yes.
It will take you to do a good job of reviewing a paper. It could take you at least half a day.
Yep.
All right. And if you're given 10 of them, do you want to spend, a full week of your time reviewing these papers? I don't.
Right.
The last paper I reviewed was for Amir.
Yes.
And I basically did it as a favor. My recommendation was not positive. And I think the paper was rejected. But, there are lots of papers like that. The problem is that people, some researchers get in a rut. They think that they have a paved road by constantly working on the same problem and tweaking it a little bit and then publishing a paper about it. How many times can you talk about how to control a DC-DC converter?
Right.
Somebody's going to come up with some kind of a little tweak and write a paper about it and then submit it, and somebody's got to sit down and review it.
Right.
So, it's a pet peeve of mine, as you've noted, that we've got too many papers, and that's also the problem with the conferences. You've got so many papers being presented at the conferences that, and so many parallel sessions, that it's very difficult to sort through them all to figure out which ones you really want to go here.
Right. I wanted to hold off on discussing this, but since we've gotten to this point, I mean, we might as well. Are you familiar with, there's an online forum called Power Globe?
Power what?
Power Globe.
No.
Okay, so basically it's an online community for power engineers from all over the world. People post technical questions there. People have posted things to like advertise for job postings, research postings. I'm looking for a job. I might post something. Somebody in the community might see something. It's a nice little community that they've created. Professor Yazdani actually suggested I join it a few years back, so I did. And I've learned some stuff from there. I've seen some stuff there. And so a couple of weeks ago, there was an issue there that somebody raised with a senior prof. And basically what had happened was this prof had engaged in some, I guess, questionable behavior in trying to influence this younger prof to support his charity of some sort by fundraising or whatever. That issue was sort of, I mean, they discussed it for a bit. That was fine. But then another issue that came up, which is something that I've sort of noticed as well, is the issue of there's a handful of faculty members or profs, I guess, or researchers across the world that seem to be producing an ungodly amount of research when you look at the number of publications they're putting out per year, per month. So the one person actually posted in that forum and said, he pulled up a bunch of names, and I won't name the names obviously for, you know, whatever reason, but there were certain faculty, for instance, who in the last 5 years had published 1,500 papers.
What?
Yes.
1,500?
1,500. They had 1,500 papers in the last 5 years.
All peer reviewed?
As far as I understand, they were. I mean, I didn't go through and look at the list, and this is something I've noticed too. And I mean, I'll send you a link to these things after. You could definitely look through them on your own time. But when I think about 1,500 papers over the last 5 years, that's basically 300 papers a year. That means you're publishing about 6 papers a week. Basically saying every single day you're publishing something. So the issue was more discussing the corruption. Obviously, these are not legitimately published papers by these people. These are somehow editors or people in positions of authority influencing the process of, whose paper gets submitted and whose paper gets accepted. First of all, I guess, do you know anything about this kind of behavior, and how do we navigate a landscape like this? Because one thing I'm starting to become discouraged by is the level of, going back to what you said, is how many times can you control, or how many ways can you control a DC-DC converter? It's like, it almost feels like we're, for the most part, most research that I see is like we're spinning our wheels, and we keep saying we're trying to solve some problem, but I don't see us actually solving the problem. Or if we do, we're acting like the problem still exists. So how do we move forward? Because as far as I can tell, it almost feels like we're starting to like hit an upper limit of what it is that we can do across the board. I feel like we've done a lot in this area of research. There's definitely more we can do, but then there are some limitations that everyone keeps running back to about for instance, the size and weight of transformers. Everyone always cites that as an issue. Energy storage is a problem, so that's an issue. And then for that reason, we have to come up with some new way to control something or some new topology. And it goes back to the exact same problem. So how do we, first of all, I guess it's two questions. One is the corruption side of it. And then the other side is, as engineers, how do we push past these sort of boundaries and obstacles that we hit when we're trying to move forward in a field? Because obviously, right now, more than ever, it seems we need power electronics to do just about everything.
Yeah. Well, the 1,500 papers a year is something I've never seen.
Sorry, 1,500 over 5 years, so it's 500 a year.
Oh, 5 years,
300 years.
Yeah, whatever. 1,500 papers in a lifetime
is
right?
Ridiculous. Yes.
Ridiculous. My experience is that, there are some faculty members who publish a fair number of papers, but my colleagues, for the most part, I think, publish good papers, and when you, as a faculty member, there are different policies that faculty have in relation to their students and how their names get put on publications. All right. So if you've got, let me take an example, Dave Perot. You know Dave.
Yep.
He's an extremely prolific researcher. He's had some outstanding students who have done some really, really good work. Mm-hmm. And they've published some exceptional papers, many of which have won prizes at the conferences. Mm-hmm. Now, someone like Dave is very selective in what he does. If you look at his papers, you will not find the new way of controlling a DC-DC converter. You will find papers directed at either one, enabling a specific application more effectively with power electronics, mm-hmm. or expanding the scope of power electronics by going up to extremely high frequencies, which is mm-hmm. what he's done, right? Yep. So there are frontiers. We have, in our field, there are frontiers. One of the frontiers is semiconductor devices, mm-hmm. right? At one point, I thought that we were sort of done with semiconductor devices. And then, lo and behold, the superjunction was evolved, mm-hmm. which is a very interesting phenomenon. It's really a phenomenon. And then we had new materials. Silicon carbide and gallium nitride became available. And they both demanded somewhat different fabrication technologies and slightly different application methodologies, especially gallium nitride. And so, papers in those areas are expanding the field. Mm-hmm. Integrating stuff, for example, switch capacitor converters. The switch capacitor converter is a very interesting converter, because it uses capacitors and no inductors, mm-hmm. right? It's got some severe limitations, but because it uses capacitors, it means that you've got the potential of putting it on a chip, because you can put capacitors on a chip. So things like that are ripe for research. And I'm sure that if you sat down and thought about it, you could think about other areas that are also ripe for research.
Sure.
People have been working on motors for a long time.
Yes.
Some people have, I can't get excited about motors, but some people get very excited. Some of my colleagues get very excited about machines, Right. My colleague, Tom Johns, who was a student of mine at Wisconsin, although he just retired, he spent his career working on machines. Mm-hmm. My colleague at MIT, Jeff Lang, among many other things, also has designed machines. Mm-hmm. And yeah, there's some interesting stuff you can do with machines, and there's some new applications that new machine designs could make viable. So, there's some excitement there. The business of the electric vehicle has opened up some opportunities for research on electrochemical storage, mm-hmm. and things like that. So I wouldn't despair that the field is empty of challenges. Mm. There are lots of challenges remaining. It's just that there are a lot of people out there who are just beating a dead horse.
Right.
Or a lame horse, at least.
Might as well be the same thing, I guess, right?
Yeah. Right.
But you've also mentioned in the past the solid state transformer, and you've mentioned how that's a key or can be an enabling technology in a lot of the things that we're trying to change in our utility grids. Can you talk about that a bit and what you think, why you think it's such a enabling or such a unique thing that would allow us to do so many or to change so much after if we were actually implement it properly? And can you talk about some of the challenges and obstacles that might be associated with it, or why it hasn't been done yet in a practical setting?
Yeah, well, the answer to your last question is easy. It's cost. In my opinion, one of the best applications for a solid state transformer would be to replace what are known as the pole pigs on power poles. You know, the transformers that you have on the distribution lines that bring the, I don't know, 1.8 kV or 12 kV or whatever down to distribution to residential levels or industrial levels. If you could replace all those with a solid state transformer, you would have control of that transformer. You would be able to sense what was happening at that location. I mean, because you've got you can communicate with it now. You could be able to sense what was happening at that location. You would be able to turn things on and off. You would be able to control the transformation ratio if line voltage is dropped. It would be much lighter, smaller. Wouldn't be as dangerous if somebody slammed into a pole with their car and the thing came crashing down. But mostly it would be an issue of you could control it. You would have visibility to the location and what was going on in the system at that point. And so basically it becomes a way of really monitoring and controlling the distribution network at a micro level almost. But the challenge is that, you know, the price of the pole pig, you can determine by just putting it on a scale.
Right.
Because it's all copper and steel. It's just commodities. How much does copper cost? How much does steel cost? Manufacturing is nothing compared to that.
Right.
And that's a hard figure to beat with electronics and controls and, you know, more elaborate exotic materials, ferrites and so forth. So yeah, I think there's a great opportunity there. And the challenge is to get the economics down to a level where it becomes competitive. Now, it doesn't have to be cheaper. It has to be competitive, which means that given the value associated with the advantages of putting that SST in place,
right,
have to be factored into whether or not it's competitive.
Right. Okay. This is something that I guess unrelated to what we just discussed, but you brought it up and it triggered the question in my mind I've had for a while. Do you know why there's a reason we don't use three-phase power at lower power levels, and why we only use it mainly for utility level applications or like motors at high power or whatever? Why don't we use three-phase power for like residential? Like why would my coffee machine not run on three-phase power? Why are my outlets in my house not three-phase power? Why did we decide to go with single phase?
It's economics again.
Is it?
Sure. I mean, to provide three-phase power, you'd have to run three-phase power down your street. You don't have three-phase power generally running down your street. You've got single-phase power running down your street. You've got three-phase power wouldn't provide much of an advantage to you in your house. Okay. You know, unless you had a machine shop with lots of three-phase machines in it, for which three-phase power would be great.
Right.
Right.
But is that something we know? Is that something we know after the fact, or is that something we knew going into this when they first designed all of this? Like, is there a reason? Did they do the analysis beforehand and say, look, the streets are going to have single phase, everything else will have single phase, but whenever we need three phase, we'll use a three phase? Or was it just that, like, are we looking at this in hindsight and saying it's economical because of this? It's the system we've built, or did we say going forward that the system should be single phase?
Well, I'm not sure. I'm not sure of the sequence of events that led to single phase in residences.
Okay.
But I can only guess that at the beginning there was just single phase AC.
Yes.
But when it became apparent that three phase had substantial advantages in terms of transmission, primarily, and advantages in the driving of machinery.
Right.
I mean, those are the two big three phase benefits. And then when you looked at what would it then take to provide three phase for residential use, and running three phase lines down a street, you've got the, I mean, yeah, you wouldn't be able to, you wouldn't have three phase, you would not have three phase, you wouldn't have appliances generally that ran on three phase. You wouldn't have a coffee machine that ran on three phase. And the reason is because it would be more expensive to build a coffee machine to run on three phases. Right. You'd have to have, a 4-prong plug. You'd have to have, heating elements that had three, depending upon whether they were Y connected or delta connected. I mean, so you can imagine how much more expensive it would be to have, appliances running on three phases. Even your television set, which there's no reason to put it on three phases. So, from a strictly economic point of view, you could make the argument, hey, let's run single phase down the street. Plenty good enough, basically a split phase, right? Plus minus 110. That's what Canada has also, right?
We have 120 volts RMS.
Well, yeah,
so more. I mean, yeah, it's the same thing, right? It's the same concept, 60 hertz, 120, 110, whatever you want to call it, So, right. What do you think about this whole idea of smart cities and IoT and integration of everything into one giant brain, I guess, this virtualization, digitalization of everything?
A lot of people are excited about it.
I don't think you are.
I think that it's way overhyped.
Okay.
There are some things that make a great deal of sense. Internet controlled lighting, for example. I think internet controlled thermostats, for example, are excellent application. One of my former students was in the middle of his master's degree with me, and he said, can I take a year off? I want to go work with some friends on a company that is designing a thermostat. And I looked at him and I said, you're designing a thermostat? Be my guest, take a year off. So he took a year off, and the company was Nest.
Wow.
And he came back, finished his degree, went back, worked with Nest, and I'm sure he's financially extremely well off today.
Yes, I actually have a Nest.
Yeah, well, I've got 5 of them at my home on the Cape, and I've got 2 of them here in my home.
Yeah. And
the ones on the Cape are fabulous because I can check to see that the house is not freezing. When we're going to go down there in the middle of the winter, I can turn them up with a
Yep.
click of a button.
Hmm.
Those applications make a lot of sense.
Right.
Do I want IoT on my refrigerator? I don't think so. Do I want to have something create my shopping list for me by recognizing every time I take out a quart of milk or finish up a jar of peanut butter, somehow sensing that that's happened? Maybe somebody does, but I don't see that as something that I would particularly value.
Mm.
There are a lot of things that you can computerize,
Right.
but you have to ask, does it make a whole lot of sense? Does it really do something that adds value to the product? Yeah.
But do you not notice that, or do you not get the sense that we're heading down that path anyways, whether people like you and I agree or disagree with the idea of a smart refrigerator or an artificial intelligence, something picking up on what it is that you're doing and sending the amount of toothpaste that you need to your house from whatever distributor it chooses because they have something going on in the back end? Like, it's already happening. Don't you kind of see that?
Yeah. I mean, it is, right. And I just sit back and watch it. I mean, there's nothing I can do to stop it. And I don't think I want to stop it because, occasionally something good comes out of it, like this
Right.
Nest thermostat, right?
Right. Absolutely.
There are, there are downsides to it, not the least of which is security concerns when you're
Yes.
connecting everything to the internet.
Right.
There's, I think there's a vulnerability of failure that is, the rate of failure may not be higher, but when it fails,
Yes.
it's history,
Absolutely.
right? I mean, let me give you an example that just burns me. I've got an iPhone.
Hmm.
Right? You've probably got an iPhone too.
Yes.
And from the very beginning, iPhone had the iPhone and the Apple computers had an app that it wasn't called music, iTunes,
Yes.
right?
Hmm.
It was iTunes. It was simple,
Yes.
right? And I had all my music. I had CDs, so I ripped them all onto my computer and downloaded them onto my iPhone, and it was easy. I had them all organized, and over the years, Apple has upgraded their systems, right? So every time I upgrade my iPhone, my music gets more and more confused. And, and somewhere within the last 6 months, I have lost my recordings of Mendelssohn's piano concertos.
Oh no.
Where they went, I haven't the foggiest idea.
Mm.
One day I was listening to them on my iPhone. The next day they were gone.
Mm.
I couldn't find them. Everything else was there, in all sorts of random order now.
Right.
But it's that kind of failure that you have no control over.
Right. Yeah, no, that's one of the things I fear the most. I mean, it's like we're starting to rely on this so much, and there was this, I can't remember what the thing was called, but there was this technology traps, I think it was, and it was like a TV. It was an old TV show, I think it was, or something like that, or it was a segment on an old TV show. Professor Yazdani shared it with me one day, and the guy basically talks about how we're so reliant on technology that all we need is one failure and the entire world falls apart. And the idea of, like, I mean, something as simple as being stuck in an elevator.
Yeah.
Right. I mean, that's like a fear for a lot of people because, like, they go into the elevator and they think they might not be able to get out of there. And I guess if you expand that to like everything, I like the world scale. If you start talking about, like, I guess cars are doing that now too. We have autonomous vehicles coming up and all this kind of things.
Right.
So,
Autonomous vehicles are really quite fascinating.
absolutely, yes. What do you think about that?
Uh, I don't know. I'm not sure I want to be driven around in an autonomous vehicle, but part of that reluctance is from a total lack of any experience of being driven around in an autonomous vehicle.
Right.
Um, I don't know what impact they would have on traffic. I don't know. I think the technology is eventually going to evolve so that it's reliable, at least in certain environments.
Right.
And a lot of people working on it. When you have a lot of people working on things, there's generally a successful conclusion.
Yes.
And at the time that Kennedy announced that the U.S. was going to fly to the moon and put a man on it, what did people think? How crazy was that? The only guy who had ever thought that before was Jules Verne.
Yeah.
You know Jules Verne's story, right?
Yes.
Yeah. But look what happened. It was an amazing feat. Truly amazing feat. So, it'll probably happen, and it'll be a useful technology in for certain applications. Maybe delivery vehicles that have routes that can be controlled. I'm not sure whether the average person who wants to go to grandma's house is going to be able to use an autonomous vehicle, but who knows?
Right. Well, because when we see things like, for instance, Tesla is doing a lot with that, right? With their FSD, and it's actually available to a lot of people. And actually, there's a guy at the gym I used to go to, and he had his Tesla pull out of the parking space and come up to the front of the gym and pick him up. And
really?
I was absolutely fascinated myself. I was like, I at first I asked him, like, is this legal? Are you allowed to do that? Like, can you just press a button and have a car driving with nobody in it? It was bizarre. It was absolutely like the strangest thing ever. It was like almost, the gym's been closed for like 2 years now, so it was over 2 years ago. And he literally pressed a button and he just kind of told me to step back because his car was coming, and it literally pulled out. And I know it's his Tesla because I've seen the white Tesla every time I go to the gym. And he presses the button and it just comes to the front. And I was absolutely amazed. And it stopped for people who were crossing. It saw somebody like walking behind it, so it kind of slowed down. It was amazing. And so it's already happening. It's just a matter of when we get there, right? So you just mentioned the. Sorry, go ahead.
Yeah, no, it is incredible. I saw years ago. I was in Italy at Renault's place, not at Renault's place, maybe it was in France at Renault, and they demonstrated for me a car that self-parked, which was intriguing. But that's a relatively simple maneuver compared to coming out of a parking spot and then finding your way to pick up your owner.
Exactly. Yeah. It's and then when you look at like the way, like, because they show like the screen and what it's sensing and all that kind of stuff, there's no way a human can even compete with that. I was just looking at one the other day where it was a car in a parking lot, and through all of its sensors, through all of its all of the sort of tracking that it does, it was able to map the entire parking lot, which car is parked where, who's coming in, who's walking, this car's pulling out, this car's pulling in, the whole thing. And it was absolutely amazing to see. And it's like, when you look at it that way, it's like it's only a matter of time before it replaces us. Because like just the other day, I saw a lady who was, I was gone for a run, and like a lady was parked, but she was pulling out of her driveway, and there was a car behind her who was literally just standing to take a left, and she just reversed straight into the car. And it's like, so if we can't even just pull out of a parking space when there's a stationary car behind us, what hope do we have against like an artificial intelligence who can track the entire parking lot? By the microsecond. So,
well, that's the argument that's being made, that the self-driving car is already, some claim, safer than a human driving the car.
Yeah, it seems to be. I don't know about. We'll see how it turns out, but so far it seems to be that seems to be the case. Sorry, you mentioned the moon landing. And that's something that I'm fascinated with, because I feel like that was the last time we as a collective were cheering towards a goal. I can't think of anything, at least in my lifetime, which I mean obviously isn't that long, but still, I can't think of anything that would have been so iconic that it would have brought an entire like the world together. It almost feels like, well, I mean, obviously there's certain people that were rooting against us and didn't want us to do it, but for the vast majority of people that were neutral, let's say, it was a huge achievement. I guess the internet is like that, but nowadays when you see what the internet's become, it's kind of not so, people aren't so happy with it, or may not be so happy with it, with all the negative it's brought. But what was the moon landing like? Like, I mean, the years leading up to it, the announcement of it, what did you think of it? How did it impact you and all that?
It was an amazing time. I mean, you're absolutely right. The country was galvanized. A great deal of the world was galvanized by this mission. And I mean, it was just amazing. I mean, there was so much focus on science and engineering. So many people were engaged with the program. And as I said, there are a lot of developments that came out of it that we're still benefiting from today. Not only Tang, but other things. You familiar with Tang?
Yes.
Yeah. It was invigorating. It was motivating. It motivated lots of people to go into science and engineering because it demonstrated what science and engineering could do, what it could accomplish. And it was just an amazing accomplishment. And you know, those of us who had the opportunity to work on that program, even for some small piece of it, you know, felt like they were part of that mission. And you're right. I can't think of anything that was as galvanizing as the Apollo mission was. I mean, there was so much leading up to it. Also, you know, there were all the Gemini and the Mercury flights before we were able to get to Apollo, and the development of rocketry of sufficient power to get to the moon.
Right.
And when you think about it, it still astonishes me that we could send somebody up there, deploy some separate little capsule that would go down to the moon, land on the moon without destroying itself.
Yep.
You know, somebody would walk out of that capsule, step on the moon, get back into the capsule, go back up, meet that same ship, satellite, whatever we wanted to call it, and then be able to navigate all the way back to Earth and come down in the ocean safely, and then step back on ground again. I mean, think about it. It's just an astonishing feat. And
so what do you think about this, like the current, I guess, generation, or this second version of space exploration going on with SpaceX and Blue Origin and other companies, and these so-called billionaires flying around in space and trying to put renewable rockets up and do all this kind of stuff? What do you think about that?
Well, I don't think much about the millionaires flying around in space.
Okay.
What I have a great deal of appreciation for is what SpaceX managed to do in retrieving rockets.
Yes.
I mean, in some sense, it's much less of a feat than going to the moon and back.
Right.
But it's still, you know, quite an extraordinary feat of engineering and control to be able to bring the rocket back and land it on a pad in the ocean. but these guys who are paying a lot of money to just go up and then come back down again after they've been weightless for a few minutes.
Right.
I mean, what are we bringing to the party with that? I don't know.
Well, attraction, I guess. I mean, isn't it a way of? I mean, I'm not trying to defend them. I'm playing devil's advocate here. Isn't it drawing attention to this again? I mean, I guess one of the things that seems to be absent from all that kind of stuff is there's no sense of wonder. It feels like a lot. Like there's no sense of, at least this is the feeling that I get when I talk to people. There's no, like, very few people are looking forward to something. Very few people are like hoping towards a better something where we do something that's extraordinary. Like we have all this technology, we have all this stuff, and a lot of it's taken for granted, whereas most of it wasn't even imaginable by most science fiction writings like 50 years ago. So I guess, is there not something to be said for that? Again, I'm not defending the billionaires, but I mean, I guess I'm speaking to the whole concept and as a whole of this space exploration and what it represents. Because if nothing else, I mean, because we can't seem to agree on anything else in terms of humans on Earth. We like most people can't even agree on the same type of soda pop they want to drink, let alone bigger differences. So I guess if nothing else, it gives us a way to unite under a common purpose, I guess.
Yeah. I don't think space exploration today has nearly the drama that the Apollo program had.
Why not?
Well, because it's derivative, right? I mean, I think the most exciting aspects of the space exploration programs we're engaged in today are the long-range missions that explore planets that are beyond our capability of stepping foot on. The mission to Mars. If you stop and think about sending a rocket up in space and then launching a mission to Mars that's going to take X years, and it's going to get there, and it's going to take minutes and minutes to communicate back and forth, and yet we're going to be able to transmit back photographs of the surface of this planet. Now, that's amazing, really. But does it galvanize a population? No, because it doesn't have, let me call it, the same tactile feature that the moon mission had.
Right.
It doesn't have this kind of sequence of events. The Mercury capsules going up, the Gemini going up, and then Apollo and the launchings, and every time there was a launching, it was on TV, and you had the accidents, and I mean it was just a dynamic environment.
Right.
It's not so dynamic to wait 5 years for the Mars rover to send back some pictures.
Yeah.
Of and no, I don't agree that the internet is anything close to something that the internet evolved.
Yeah.
When things evolve, they're not as exciting.
Right.
No, unless there's some kind of a breakthrough. You need a breakthrough. You need something that says, "Wow, now all of a sudden I can do something that I could never dream of before."
Right.
I don't know what that is today.
Yeah, like I said, we seem to be missing that, and I think, well, I don't know, maybe that has something to do with the lack of interest, I guess, that I see, at least. I mean, because even when, or maybe I have a skewed sample of what it is that people are into these days, but very few people are interested in that kind of stuff. Very few people seem to be interested in engineering. And I guess this is another thing I wanted to ask you, because I've noticed even when I teach some students, they're in engineering programs and they're in their 4th year, and even they seem kind of uninterested in the engineering. Does that exist at MIT?
Probably to some extent, yeah. I mean, my students know that I cringe when they tell me after they graduate that they're going to the dark side, that is to work for some consulting company or some financial company. That's not engineering.
Yes.
You know, I mean, it depends on the consulting company, but the kind of companies they go to are generally management consulting companies, you know, where yes, technical knowledge is of value, but you're not really engineering anything, in the classic sense anyway. And you know, perhaps the lack of enthusiasm goes back to what we were discussing earlier, which is that there aren't as many tactile opportunities for them in engineering.
Right.
You know, they can't immediately put what they're learning to work. They can't well, some of them can. You know, the entrepreneurial spirit seems to be alive and well,
yes,
among our students.
Mm-hmm.
And that's great. And a lot of engineering results from that. They start a company that is an engineering company, manufactures a product, takes their thesis and builds upon it. So there is that, which is very encouraging. But I guess I don't really have a good feeling for how excited students are today at the undergraduate level in engineering. I do know that, you know, the computer science side of our faculty have far more students than we do on the what I would call the electrical engineering side. So there's, you know, and this also is reflective of what we discussed earlier about
Yes.
the draw of computer engineering or coding.
That's actually a trend that's also apparent here. It was made apparent to me a few days ago that the University of Toronto, apparently their electrical engineering program is declining in the number of students that they have. And I believe the computer engineering and the computer science, I guess the software engineering is part of the computer engineering program or something like that. But those programs are starting to increase in their popularity, and electrical engineering is definitely declining. So that's certainly a thing.
Yeah,
seems to be
but it may also be due to what they perceive to be the opportunities once they graduate.
Mm-hmm.
I mean, they're you know, what are the companies that you would go find a job in where you could exploit your engineering degree? Well, there are some, but there aren't as many as we used to have. You know, there were lots of real research laboratories associated with lots of companies, right? Bell Laboratories, RCA Laboratories, GE Laboratories, Fairchild Laboratories, Texas Instrument Laboratories. These were big operations that were making major developments, major advances in technology that were then being used in the companies to produce products. You know, the management of these companies has changed in a way that has made those whatever laboratories remain, and it's made them focus on being relevant to the businesses. Now, that's okay, but and it's certainly better probably for the bottom line of the companies and their stock price, but it does not engender the creation of new knowledge the way the old research laboratories used to. And they do not offer the same opportunities that somebody graduating with a master's or a doctorate had back then. So what was the genesis of this this reflection?
The idea
Whether
of
excited about,
the decline of electrical engineering,
yeah,
and the rise in computer engineering, and so on,
yeah.
and me noticing that some students are uninterested in what they're doing. So
Yeah. Well, Sandeep, there's another issue that I've thought about. Computer games are just rampant, right? I
yes,
mean,
yes,
and a lot of kids growing up these days are engaged with computer games, and they have to be torn away from them by their parents setting down some rules about screen time and so forth. And coding is a computer game.
yes,
And so if you really like computer games, then you'll get a big buzz out of coding. Right? Maybe, and I'm not familiar enough with what the jobs are that a lot of these computer engineers do. But I would imagine that many of them work on some small piece of a larger program.
for the most part, from what I understand, yes.
And yeah, and so they have to get an output that is ABC or something. All right, and so it's a game. So let me code this, and they can sit at the keyboard and they can try this, and it doesn't work, and they can try that, and it doesn't work, and they can go back and they can find out where the error was, and that's really cool, and I feel good. My endorphins are high because I fixed that problem, and it's all on the keyboard. So there seems to be a similarity between the joy that kids have in their obsession with video games and what makes these computer guys tick.
Right. But what does that do to a person? I mean, you've also talked about the value of collaboration and interpersonal discussion when developing new ideas. What does a job like that, where somebody is spending a lot of time on their own, although they do have discussions and they have these meetings and so on, but the vast majority of the work these people do is, I mean, I guess I do the same. I sit, because of the nature of the work we do a lot of simulating before we run into the actual experiments. What does that do to I guess, this is a type of creative process, right? When we're doing research and we're trying to determine a solution or something, usually there's some creativity involved in the solution, in the process, in the way that we're applying ourselves to solving these problems. When you're spending so many hours on that type of stuff on your own, is there anything to be said about our skills as people, and what happens to us as individuals?
Yeah, it's a good observation. The task itself doesn't preordain that you're going to be antisocial, right? The environment in which you're working has much more of an influence on that. So even if you're sitting in front of a computer screen, and writing a book is a lot of sitting in front of a computer screen. If you're in an environment where you are in touch with other people, and I mean in touch, that is, you are
physically there,
you can see them, you can hear them, you can have coffee with them, you meet them in the men's room or the ladies' room. You have discussions about what it is you're doing. I think if you have discussions about what it is you're doing, you're okay. It's when you are completely isolated in terms of your task that things start to fall apart, I think, in terms of a person's personality. If you're working in a laboratory, like my lab at MIT, and you got your student colleagues are around you, and your faculty is around you, and when something blows up, they all come over and they, what happened? And you have a discussion about this, that, and the other thing. Or you have a problem and you need some help, and you get somebody come over and you got to explain what it is that you're doing and what happened and so forth. Those interactions are very much learning interactions. And if I don't know whether they occur among people who are sitting at a computer coding all the time. And I don't know how you would find that out, but I think if it doesn't occur, then you've got to make time in your life for something else as well.
What do you mean by that? Something else? Like leisure?
Yeah, you need a hobby.
How
That's
important
not-
is that?
That's not coding.
How important is that?
I think it's critical,
Okay.
but that's only one man's opinion,
Okay.
because I take great joy in the hobbies I've had, and still have. I've gotten I mentioned my colleague Tom Johns at Wisconsin. He just retired. And so we were emailing back and forth, and he was complaining about, the work he was still doing and so forth. And I said, what you need is a hobby. You need to get a hobby.
Right.
And he responded, he said, yes, I do. I need a hobby. So, and my last text to him was, have you gotten your hobby yet? I haven't gotten a response. But it's got to be, it doesn't have to be completely orthogonal to your work necessarily, but it should be enjoyable. It should give you some sense of accomplishment, or at least a sense that you've enjoyed the time that you just spent on it, whatever it is. Even if it's knitting. I had a very good friend who used to knit, and he enjoyed it.
Yeah. Right.
He knit each of my kids when they got married a blanket. So, it's a hobby, and
Right.
it was something that he enjoyed doing. You need it.
Do you do
What's your
anything
hobby?
besides? Sorry. Do you do anything besides fishing and sailing? I know
Oh,
you do
yeah.
those two. What else do you do?
For the past several years, I've gone up to Maine for several weeks at a time to the wooden boat school, learning how to build wooden boats.
Oh wow.
I've got a greenhouse. I like to garden.
Okay.
I really enjoy woodworking.
Yes.
I've got a nice shop.
Right.
Yeah, a lot of different things.
I actually engage in woodwork. I've been I spent the summer mainly learning a lot of that kind of stuff. Mainly, I usually use the summers for that type of stuff. I'm into art and drawing and painting. That Spider-Man in the pit back there, I've actually drawn that and painted that myself.
Is that right?
Yeah, as well as the Wolverine. I have a bunch of others. I used to engage in it much more before, and I'm ashamed to say that I don't so much because it's just time, I guess. But these days, the main hobbies, I guess, these days for me are exercising. I guess is a hobby and a form of therapy. So I spend at least an hour or two every day trying to do some type of workout, whether it's weightlifting or running or biking or something. So much so that I had to actually build a gym in my basement once the pandemic hit because I just couldn't survive. I tried for a while. I was doing I had bags of rice and flour that I was trying to work with, and it only got me so far. And then so I got a bunch of lumber. I put it together to build a sort of a wooden rack to hold the weights. I made a barbell out of a bunch of different stuff. I made some dumbbells out of concrete, and so So I've been managing that way.
You engineered your weight room.
Exactly, I did. I'll send you pictures. I was proud of it. It turned out really well, and there's a lot of weight on there too, so it turned out to be pretty strong.
Good. Yeah, I'd like to see pictures. But doing something like painting or drawing that takes your mind completely off
Yes.
your research
Right.
is a way of invigorating your intellect.
Mm.
You know, when you come back to it, you often are, you have greater visibility to what you've been doing. I mean, I often, you know, I spent a lot of time while we were writing this book. I spent a lot of time writing or creating a problem or trying to find a solution to a problem with LaTeX or something. And I will often find myself sort of in a fog at some point, and I just leave it, and I go and I read a novel or something, or I go down, have a cup of coffee, or I go down in the cellar and work on something else. And when I come back to it, I have better insight to what the issue was.
Right.
And oftentimes I can move forward and get over this hump. And so I think it's important for people to have some way of digressing from their major activity.
How do you draw the balance though? Because for me, one of the things I struggle with the most is actually I mean, because look, I know taking time off is good. It makes me more productive in the long term. It makes things more sustainable. It does, it does wonders for you when you're stuck somewhere and then you completely forget about the thing and then you come back to it a day or two later. The solution like jumps at you basically. Mm-hmm. But it almost feels like in the moment, or when you're trying to force yourself and you're trying to pull yourself away from the thing, it almost feels like I almost feel guilty that I'm not doing what I'm supposed to be doing. And then for someone like me, there's also like a timeline I have because I'm trying to finish something. It's not so much like it's an ongoing process that will finish. Like I imagine it's different when you're working a job, because when you're working a job, it's like, look, I'm going to be here again tomorrow and there's no end of this. I collect my pay at the end of the week. Life goes on. But at this moment, it almost feels like because I'm at a point where like I'm trying to finish a PhD, let's say, I'm trying to move forward professionally, it almost feels like everything else is hanging on this. So one of the things that I struggle with is pulling myself away and saying, okay, look, you know what, this needs to be left alone for a day, 6 hours, 12 hours, whatever it might be. Come back to it later and then try to approach it again then. Do you have any advice as to how you can deal with those kind of issues?
Advice is cheap, right? And the problem you describe is universal, especially among those of us who are engaged in the kind of never-ending activity that research is. I guess I would just say, you've got to discipline yourself that stepping away is productive, and that in fact stepping away will make stepping back, it will make when you step back, you'll be able to work more efficiently. That you should view stepping away as kind of a rejuvenating activity rather than an activity that is delaying progress on your work.
Right.
It's just discipline. I mean, it's hard. When I put down the pen and leave, and I haven't solved the problem, it takes a recognition that if I stay here, I'm still not going to solve the problem.
Okay.
Right.
Mm-hmm.
I'm still not going to solve the problem, and the only hope is to leave.
Right.
For a while.
But you don't ever have this part of you that says, if I stay here for 5 more minutes, I might solve the problem? Sure,
I do.
So then, how do you get rid of that?
Well, there's there is a conditional in there, right? I might solve the problem, right?
Yes.
So, but there comes a point when you can't. The other thing is that even if you are not at a point where you're saying, "Hey, I'm stuck," you should recognize that you just got to take a break. You know, go have a cup of coffee or whatever you drink. You know, and you know, let your mind relax a little bit, knowing that when you come back, you know, whatever you were working on will still be there. Now, I think it's wonderful that you take an hour or two every day for exercising. I don't have that discipline. I don't have that energy, I suppose, either.
Well, I mean, for me, it's been like I start initially when I didn't initially when I first started my undergrad, and I started after about like the third year, I think towards the end of the third year of my undergrad. And then I started to notice that like I just felt better overall. And then now I start feeling depressed if I don't. So I do it out of necessity. It's not even because like I mean, people always like, how do you stay so disciplined and motivated? I'm like, I'm not most of the time. It's just if I don't, I'm going to be miserable for the rest of the day, and I want to save myself that misery. So I'd rather go for a run or something rather than, you know, just sulk in my sorrows. So
well, that's a danger too.
Yeah.
That you get addicted to the exercise.
Yes.
But that you can't not do it.
Yeah.
You
I
know?
have a very addictive personality, very obsessive personality. That's one of the things that I struggle with the most is when I start doing something, that's all I want to do. So I have to be very careful about the things that I do. So I've started to notice I can't really like watch TV or movies anymore because I get too obsessed with the storyline or something like that. So I just can't. For that reason, I don't even read books anymore. I mean, if I read books, they're usually nonfiction books because I know that there's some logical ending, hopefully, unless it's something philosophy related, in which case I'm screwed either way. But that's something that's definitely part of the personality, I guess.
You know, reading a novel is a very relaxing thing.
Yes.
Because it transports you once you allow yourself to be transported.
Right.
You know, reading. I enjoy reading nonfiction. Mostly I read nonfiction.
Mm-hmm.
But I almost always have a novel sort of lurking somewhere.
Mm-hmm.
Because a nonfiction is it's fascinating, but it's not immersive the way a novel is. You know, novel, you're there. I mean, if it's a good writer,
exactly.
You know, or you're just engaged with the protagonist. So you should at least give novels a chance every once in a while.
I've tried to. Like I said, I obsess about the stories and the characters, and they live on longer than they probably should, and I can't just put them away when I close the book, and so it tends to be a distraction after, because I'll be like working on like my research, and I'll just be thinking about some story that I read at some point, or something else or another, and so it's I really enjoy it. It's not that I don't enjoy it. It's just it almost feels like a hangover after you're done.
And hangovers go away eventually.
Yeah, but I mean, you still feel like it's still hell for as long as they last, right? So, I mean,
you wanted advice. I told you advice.
Yeah, I know, 100%. I agree. I will definitely give it a shot, but
what you pay for it.
On the same topic, I guess it's one of the things that I've talked to other graduate students. I've even talked to some faculty members and profs that are well into their careers. Are you familiar with the idea of imposter syndrome?
The imposter syndrome? Yeah.
Yes. Have you ever experienced that? Or do you experience that?
Yeah. I mean, basically the imposter syndrome is a sense that you don't really belong here.
Yes.
You know, that somehow you're faking it.
Yes.
And sure, I've occasionally felt that. But so what? I mean, I think that everybody I think if you don't ever feel that, there's something wrong with you.
Why? Why is it essential?
Because it's humbling. provides a realistic perspective on yourself. You know, the fact that you know that maybe you're not quite as good as everybody else thinks you are. Now, you got to be careful, because the syndrome could drive you nuts if it was really severe, I suppose.
Right.
But, you know, occasionally feeling like, what am I doing? How can I do this? You know, I don't have the energy for this, or yeah, I think is healthy. It kind of resets you in some sense. So, yeah, the simple answer to your question is yes.
Well, I mean, it's comforting to hear. This is one of the things that I really enjoy, because when I get to, you know, speak with people who are much further along in the process than I am, it brings some more relatability, and it lets me understand that I'm not completely crazy, although I'm convinced that we all are slightly.
Yeah, we all are slightly.
Yeah, slightly, right? So I mean, so it's good to hear that. Do you have any insight on how, or can you comment on your approach, let's say, to solving complicated problems when you face them, whether they're technical, whether they're I guess like internal conflicts, what do you have in your mind? I guess let's say from two different aspects. One would be the engineering approach. So if you have a complicated engineering a problem, do you have like a certain, almost like a checklist of what it is that you go through when you're trying to approach a problem?
No, I don't.
So every solution is unique in your mind then?
Probably not. But I've never, you know, I've never thought that I had a codified process for addressing problems, technical problems. I guess if I had to kind of define how I go about it, I guess the first thing would be to fully understand what the problem is. Understand what the parameters of the problem are. Certainly understand how important the problem is. I'm going to be spending a lot of time on it.
Right.
And then think about the tools that could be useful in solving the problem.
Right.
You know, I'm skeptical of people who feel they have this rigid approach to problems, and then state them sort of unequivocally, this is how I do it.
Right.
I just don't believe that's how you solve problems. I think, while each problem may not be unique, I think one's approach to problems can be unique to the problem.
Right. I mean, I guess solutions are messy, right? That's another problem usually.
Yeah, solutions can be messy.
Right.
I mean, if you go down the wrong track, you got to back up, right? So.
And how do you know you've gone down the wrong track, and how do you know when to back up? Because that's also not obvious.
Well, you know, suppose you're trying to crack an integral, right? Which I haven't done in ages. But there are multiple ways of approaching how to integrate something.
Yes.
Integration by parts, integration by this, that, yeah. So you start using one technique, and you get to a point where you can't see how you would proceed.
Right.
Right. So you back up. you take another look at what the integrand is. What can I do with this integrand? Is there something I can massage here that would put the integrand in a different form, that would allow me to use a different tool on it? And then you proceed with that. And maybe you're successful. Maybe not. And then you go back again, and then after you're completely frustrated, you go to the math department and you find somebody who can help you out.
And hope that they have an answer, right?
And hope that they have the hope that they can answer it.
And if they don't, then you're totally screwed.
You're screwed. And that then raises the issue: was this problem worth working on in the first place?
Definitely. Can you at all elaborate on the difference between academia and industry, and I guess the type of people that, or the type of work that one does in industry versus academia, the nature of the work, the nature of the people, the process? I know, I'm not sure if you have, as far as I understand, you don't have extensive industry experience, like working in a large company for a very long duration or anything like that. That's my understanding. Is that correct?
Yeah, that's correct.
Right. So, but you've done consulting work with the industry.
Yes, I have.
So
yeah.
Can you comment on the kind of problems that they approach, that they try to solve, the way they address them, the type of people that they are versus, I guess, the nature or the environment of academia? Because I've always heard this thing that people in industry call academics, like they say academics are purely have book knowledge and have no idea what's going on in the real world. And then that academia usually thinks that industry people are like not at the same level as them because they don't understand all the theory. Also, I guess like an equivalent argument is often made between physicists and engineers, because we tend to water things down and to take them for what's practical, and they tend to want to have everything defined purely, properly. Yeah. And then I guess the same argument's also between physicists and mathematicians, because physicists also cut corners when it comes to the math. And so, can you comment on, I guess, the relationship between the two, the differences, similarities, and so on?
Well, first of all, I think that the expressions of the dichotomies between, engineers and scientists and academics and industry people and so forth is overblown. I don't think that most engineers feel that academics are just book learners, and I don't think that most academics feel that engineers don't know what they're doing.
Okay.
I think it's considerably the other way, that there's a high degree of respect between the two. As far as what might be the difference, one difference is that the engineer in industry, he goes home at 5 o'clock and that's the end of the day for him, right?
Right.
Professor's day is never over.
Yes.
Right. The other difference is that in general, the engineer in industry has a specific task. It's a task. It's he or she is building something, whether it's a computer program or some hardware to create some function. And the purpose is not to uncover some underlying physical law, or to uncover an explanation for a phenomenon. Now, that may happen in the course of the industrial engineer's work, but it's much more the focus of an academic's work.
Right.
The issue of an academic not knowing what goes on in industry I think is it it can't be generalized. I mean, through my consulting, I've had a tremendous amount of contact with industry. And I've designed stuff for industry. I designed the system that maybe I might have mentioned this.
The Cheerios?
Yeah, the cereals thing.
Yeah.
And you know, it was a long-term thing. I got a lot of exposure to what was going on in General Mills plants and so forth, and how you go about manufacturing this thing, how you go about installing it, how you go about educating people about the thing, how you go about seeing how it performs relative to the alternative, and so forth.
Right.
So if a faculty member is engaged in consulting, faculty member in engineering is engaged in consulting, there's no reason to believe that he or she doesn't have an appreciation for the practical application of what it is that he or she is teaching. But in some respects, there isn't a lot of difference between the academic engineer and the industrial engineer. I mean, they're both engaged in somewhat similar activities with somewhat different ends, I guess is what I would say. You know, the missions are slightly different. The technologies and the understanding and backgrounds are more similar than different.
How does one get into consulting type of work? And how common is it for academics to do consulting work, I guess, in a field like ours?
Yeah. I don't know the answer to your last question.
Okay.
That is how difficult it is, because it depends upon what your particular discipline is and how industry needs your discipline. One kind of consulting that I have done very, very little of, and only very selectively, is legal consulting. And I've only done legal consulting where there was an engineering problem to be solved. And those were almost always issues of somebody being electrocuted. My other consulting has always been related to solving an engineering problem in industry, that something isn't working, how do we make it work? Or in the case of General Mills, how can we adapt a new technology to our processes? And you know, being at MIT, if a company wants a consultant, they will go to places where they think they can find the resource. So, you know, the imprimatur of MIT was clearly very instrumental in my ability to attract consulting. It's not that there weren't lots of other people who could have done the same thing, but you know, General Mills didn't go to these other places.
Right.
They came to MIT, and the people at MIT sent them to me.
Right.
And then, you know, once you start consulting, you get a reputation, and you know, people will come to you.
Right.
Also, you develop a relationship with companies. For example, I worked as for a summer as a senior staff scientist at Gould Laboratories.
Okay.
And so for many, many years after that, I consulted for Gould Laboratories, you know. Maybe once a month I would go out to Illinois for a day or two and consult for them.
Right.
Very early in my career, I was approached by a fellow who started a lighting control company, Lutron Electronics. I don't know, I might have mentioned that in the talk. I don't know if I did.
I think so, yeah.
But he had started this company. It was a small company. They were making light dimmers. And he came to MIT. He just showed up on my doorstep, basically. Knocked on my door, came in. We had no appointment or anything.
Right.
We started talking. It was, you know, I think I was in maybe my second year as assistant professor or something. He had found out that I was working in power electronics. He wanted someone to teach power electronics to his engineers.
Right.
So I put together a curriculum, and I went out there once a month for a couple of days. I taught them power electronics, and they were an expanding company. And so every year they hired, you know, a dozen new engineers. And so every year I would spend some time during the summer going down to the company for a week and teaching the course. And then I would also consult for them during the year on a regular basis on problems they had. So it's those sort of relationships that generate your consulting. Most of the time, you have sort of long-term consulting relationships. Those are the ones that I really value, where you have a long-term consulting relationship with a company or a part of a company. And that, you know, you develop, what's the word? You develop by happenstance, I guess, you know.
Right.
Happy events occur and you develop a relationship.
Right. Speaking of, I guess, developing relationships and such, you mentioned Professor Shashi Dewan in your podcast with the IEEE.
Oh, yeah.
And I actually have some ties with him because not only did Professor Yazdani work for him for a short period of time, the founder of our power electronics lab at Ryerson was actually a student of his, Professor Ben Wu. Ben Wu, yeah, was a student of Professor Dewan's. But I've heard a lot of stories from Professor Yazdani about, he used to just refer to him as Professor Ben Wu's former supervisor for the most part. And I hadn't heard what the actual name was. I think he mentioned it maybe once or twice, but then you mentioned it and I was like, that name sounds familiar. So then I pulled it up and I did this and that. And so I said, I just have to ask because you mentioned that you came up to Toronto and you said that he was quite a character. And I've heard a similar description of him from Professor Yazdani. Do you have any interesting stories or anything you'd want to share about Professor Dewan?
I admired him greatly. He was dynamite, a real dynamo, a real engineer. He did some great work in induction heating. He had a great laboratory in Toronto. I don't know if this stop me if this story appeared in my discussion at Senadet, but he invited me up to Toronto, and so I flew up and I arrived early evening, and I think we had dinner together. I don't remember the dinner, but then he wanted to show me Toronto. All right. And so we got in his car and we drove all over Toronto.
Mhm.
he was pointing out this and he was pointing out that and the other thing, and the night was getting late, and I just was wondering, when was this ever going to end? And he was just a firecracker. He's just completely oblivious to the fact that, it was getting close to midnight, and I had been on a plane, and I had worked
Right.
all day, and you know, and then of course the next day in his laboratory, it was the same thing, except
Mm.
that we were going all over his laboratory.
Right.
Um, yeah, I really admired him. Uh, he was a great guy. I lost contact with him, um, and he died, didn't he?
Yes, I think it was in like the late, I think 2009 or 2008, around that time.
Was it around then?
From what I understand, that's what I've heard. Yes.
Right. I mean, it just shows how lost my contact with him was, because he was also, he didn't really participate much in the professional societies. I don't remember him ever at a conference, which of course, if you don't go to the conferences, people lose track of you.
Right.
You're not visible anymore. You can publish papers, but that's not the same as face-to-face contact.
Right.
Yeah. No, he was a leader in the field, really. He with Strawn published, Dewan and Strawn, the book on, what was the name? I've got the book because I'm home here. I don't have the title here, but it was Power Electronics or something like that.
Mm-hmm.
You familiar with the book?
I've heard of the book. I haven't seen it. I have not, nor have I read it. Professor Yazdani has mentioned it to me a few times, that they have a book together, and that apparently Strawn was, I don't think he had a doctorate, from what I understand, and they had given him basically, I think it was Professor Dewan and Professor Sleman had given him their lecture notes, and apparently he had compiled a textbook for them. That's how the anecdote goes, from what I understand.
Well, Gordon Sleman wasn't really in power electronics.
No, they have a machines book together, I think, or something along those lines.
Yeah, this is Dewan and Strawn, Power Semiconductor Circuits, 1975. Yeah.
For the most part, these are older books that we would have never been exposed to, obviously, but your book is one that I'm very familiar with, and so I've always been interested in asking, like, how does one go about the sort of gargantuan task of writing a book about something like power electronics, and what first gives you the confidence that you'll actually be able to do that, and then how do you actually approach the problem once you've decided it's a good idea?
Yeah, that's a really good question. Okay, so starting from the beginning, how do you decide you want to write a book? Okay.
Sure. Yep.
Well, if you're teaching a course, and let me just use myself as the example. So I'm teaching power electronics. Been teaching it for a number of years. I've got lecture notes. I've got problems. I've got an understanding of the material. I don't find any other book available that I feel is appropriate. In fact, at the time we wrote that book, it was, I think it was the first textbook in power electronics. Mohan's book came at about the same time, I guess. So you want to write a textbook. I like collaboration. And so I engaged two of my colleagues, Verghese and Schlecht, to write it with me. And Marty Schlecht was one of my former graduate students. He, at the time we wrote the book, had joined the faculty.
Right.
And so he knew a lot about power electronics. George Verghese was in our laboratory. He was a controls guy.
Yep.
Was interested in power electronics at that time. And the three of us were good friends. And so we decided to write this book. And, you know, started out with my notes. And the need, the presence of co-authors provides a degree of both encouragement and a sense of obligation that kind of keeps you moving towards a result.
Right.
And it's a long process.
Yes.
And now one thing that made it, I think if we hadn't done the following, the book would never have been, we would never have finished it. But MIT has in the month of January, at the time we were writing the book, MIT had just created what was known as the independent activities period, which was the whole month of January, no classes.
Oh, wow.
And lots of activities that were provided by faculty and non-faculty, and students provided stuff, and you could do this, that. I mean, it was at the time, it was a really exciting time, but we had no teaching obligation. Marty wasn't married. George wasn't married. I was married, but I had a very understanding wife, still do. And we had a place on Cape Cod, summer home on Cape Cod, which is basically, it's a 4-year house. So the three of us would go down at the beginning of IAP. We would go down for 3 solid weeks and live there. We would take our computer down, a printer, the tech manual, and we would just write.
Right. And
we were able to consult with one another about issues. You know, in the evening we had good times. You know, it was a lot of fun, right? And we did that, I think, for 3 running years.
Okay.
Before we finally got to the point where we had a manuscript. Now, that was my experience with the first edition.
Right.
The second edition, of course, builds on the first edition, but there's a hell of a lot of new material. And so I asked Dave Perrault to work with me on that, because he in particular is very familiar with a lot of the new material, especially the very high frequency stuff, magnetics, control. And then George Verghese joined us to rewrite the controls chapter.
Right.
Marty is not, although his name will be on the book, he hasn't contributed anything to the rewrite. He's not in academia anymore. He started a company, and he's retired. So,
oh, wow.
Yeah. So that's the process, my process for writing the book. It's a long, tedious process, but once you complete it, it feels real good to have that book in your hand.
I'll bet.
Yeah.
So you've commented, I mean, you just, I guess, alluded to the importance of it, and then you've also commented on this before, the idea of disconnecting and being able to just work. How do we do that? How do we allow ourselves to do that, given Like, for instance, 3 phone calls you've already gotten today in this conversation, number of emails dings that you've gotten, the number of email dings that I've probably gotten. Mine are obviously less important, which is why I put my phone on silent. So I tend to ignore people more than I probably should, but it's okay. How do we put in a system like that in place, and how do we let that be okay when we are? I mean, for example, I can't set a culture like that. But if I were to somehow be a manager or a supervisor, or an academic, like a prof, a faculty member, and I have students, what kind of things can I put into place to make sure that students have that, ability to disconnect when they need to? Because it doesn't seem to be the case that very many can disconnect, or if they can, they feel like they shouldn't.
Yeah. Well, one thing is to turn off the dings. I don't let my computer ding on email.
Okay.
I get dings on text messages, but not
okay.
email. I mean, email has been it's a very insidious invention.
Mm-hmm.
You're constantly connected. And there are books that have been written about it.
Yes.
The only way to disconnect from it is to disconnect from it, I guess.
Right.
My son is in California,
Mm-hmm.
and he and some other of his friends from MIT started a company which they recently sold just before the pandemic. They sold to Twitter. Or Twitter bought them.
Mm-hmm.
And so now he works for Twitter. But Twitter gives them, every once in a while, it seems to me almost every week, although it's not always every week, he says to me, oh, well, tomorrow we've got a day of rest. They can turn off all their computers and stuff, and they have a day of rest.
Right.
Hold on a second. We just got a dinner invite. So,
that's good. It's always nice.
Okay. Yeah, so you just got to pull the plug, I guess. I mean, it's a question to which I have no good answer.
Yeah.
It's hard. I find it hard enough myself to kind of disconnect.
Well, Ontario actually passed, or I think they're passing a bill, or they have passed a bill. They've made it illegal for employers, I think, to contact employees after work or something along those lines. I haven't read the details of that.
Wow.
But apparently that's being passed, and I don't know to what extent it'll actually be enforced, or if it's just for show, which most things seem to be these days.
That's going to be a tough thing to enforce, and I'm sure there are going to be a lot of exceptions to it.
Yeah, which is, I mean, it's weird that we put this kind of things into place too. I mean, like, there's a lot of policies like that come into place that don't make much sense, or are backed by these kind of weird ideas, I think. One that comes to mind that I guess is also something I've wanted to ask you about is, I don't know what it's like at MIT, but I know some places in the States are actually going pretty crazy about this stuff. Places in Canada are also going crazy about this stuff. This idea of, like, equity, diversity, and inclusion driving just about everything these days, or EDI, they call it, right? Are you familiar with all that?
Oh, yeah.
What do you think about that? That whole, like, culture, like, I mean, like, the simple word for it is they call it woke culture, right? Or the social justice culture, whatever it is. What do you make of all that stuff?
Yeah. Well, look, I think that the mission of that culture is good.
Mm-hmm.
That, there are a lot of minorities who have been excluded.
Yes.
There are a lot of women who have been excluded.
Yes.
There has been a lot of discrepancy among how different groups are treated in various environments. So I think raising sensitivity to these issues is good. I think there's been sort of an overboard reaction to the need. I don't like the expression woke culture. I'm not even sure quite what it means, but it's been used abusively. There's a lot of people are giving it a lot of thought,
Right.
trying to be responsive, I guess. You know, it's one thing to set up the Office of Equity, Diversity, and what is it? Equity, diversity,
Inclusion.
and inclusion.
Hmm.
One thing to set up an office with somebody in charge, you know, the EDI vice president, but you know, it's another to make it all happen.
Right.
So
what do you think about things where, like, there are certain places where they're actually taking action on these things? Like, I know in New York City, for example, or maybe it was the state of New York, they were saying they want to ban all gifted programs for gifted students because those are somehow skewed towards certain demographics and not others. So we should get rid of that altogether. Or like in Oregon, for example, I think the state tried to pass a bill where they said high school students shouldn't need math and English to graduate because the students that primarily go into those or that excel at those areas are of a certain group, and therefore they're excluding the other groups.
yeah.
So what does that do to us as a society, especially when there's obviously a need for technically competent people? Like, we need more mathematics, we need more engineering in all of the things that we do on a daily basis. What does that do to us when we're seeing that the things that got us to where we are right now are basically being attacked? There's like an attack on meritocracy, on being a competent person, on having skills. It's almost seen as like if you have a skill, it's because you kind of took it from somebody else, it almost feels like.
Well, I think Sandeep, you're overstating it.
Is that
I agree that some of these programs that try to make access to what used to be the gifted programs, some of the approaches to try and create some equity there are like taking a sledgehammer to it.
Yes.
However, I firmly believe that there is a need to recognize that there are people who would be qualified for those programs who don't have the resources
Mm-hmm.
or access to them.
Yes.
So the question is, how do you provide that without denying it
Mm-hmm.
to others who are equally qualified?
Right.
You know, we have it here in Boston, not to the same extent that you described in Oregon or in, I don't know
New
where
York.
it was.
New York was
New
the
York,
first one.
New York. You know, there are, Boston has a couple of high schools that are called exam schools. So you have to pass an exam. They're public, but you have to pass an exam in order to get into them. So
Okay.
they're selective. But you know, those students whose parents have the resources to provide tutoring, and not just tutoring, but to provide the environment for when the student comes home, has a place to work, he has somebody to ask for help. You know, he has parents who are watching over him, looking out for him. Those students have the resources, their parents have the resources to also give them tutoring if they're falling short in some area.
Right.
Yet there's another whole category of students who come from families that are not as blessed. They are not as well off, may have two working parents, each of them working two jobs. They aren't home when the student gets home. They aren't monitoring how well their son or daughter is doing. And so even though this particular student might have in the innate capacity to undertake a curriculum and then in one of these exam schools. He's denied that because he doesn't have the ability to pass that test
Yes.
at the present time. So,
Right.
you know, there's a lot of controversy about how do we deal with that. Well,
Right.
one thing they did was they still have the exam. No, I think they got rid of the exam, at least temporarily. They got rid of the exam
Okay.
and they are using two other metrics. One of them is your performance in grade school, through the 8th grade,
Right.
and the other is your zip code.
Hmm.
Because by zip code, at least in Boston, you can identify where the more underprivileged children are living.
Okay.
So if you can combine one of their one of the students from that zip code having decent grades with being in that zip code, there's a thought that, okay, this student, you know, let's give him a chance.
Right.
Very controversial,
Yes, I can imagine.
highly politicized,
Mm-hmm.
a lot of unhappy parents,
Mm-hmm.
you know, for the 8 years their kids were going through the process of grammar school, felt that they were all ready to take the test to get into this exam school, and now there's no test, right? And they're now competing on zip codes and stuff. So it's an awful, awful problem. And,
Right.
and I don't know what the solution is.
Right.
I don't think anyone knows what the solution is yet.
Mm-hmm.
And you know, until we somehow deal with the issue of poverty in this country,
Right.
or at least quasi-poverty, you know, which I think President Biden is trying to address to some extent. Of course, he's trying to deal with the Congress that's intransigent.
Mm-hmm.
At least half of the Congress is.
Yeah.
You know, until society comes to grips with the problem somehow, it's going to be continuing to be with us. Do I agree with how it's being addressed now? Not entirely.
Mm.
Do I agree we have a problem that needs to be addressed? Yeah, absolutely.
Right. Yeah, I think that's the same sentiment here. I mean, like, I 100% agree that the issues we have, for instance, like I mentioned to you a while back, that Ryerson's planning on renaming the university. And they've actually gone ahead and they're deciding they're going to rename it. I think the new name is going to be announced sometime in the next month or so. I don't know when it'll be, but they said, I think by the end of January they were saying they're going to announce something. I don't know, but I feel like these solutions that people are putting forth they're trying to put a band-aid over a wound, and they're not trying to actually go in and solve the actual issue. Like, if you imagine for a second, you've renamed a university, you're rebranding the entire university basically now. The amount of money and all this effort that's going into doing all this stuff, they're actually changing the name of the street that the university is actually. So I don't know if you remember, but the heart of downtown Toronto is at Yonge and Dundas Street. Dundas was apparently some type of Scottish something figure, like, of merit or person or some notable person. I don't know.
Yeah.
And his name appears all over the city because it's a street. There's schools named after it. There's a city in Ontario named after him. And so now they've seen that because he was a slave owner, they have to change the name. It's similar to what happened in, I think, New York City Hall got rid of Thomas Jefferson's statue, right?
Yeah.
So issues like this that are coming up, I mean, like, it feels like we're almost just like we're dancing around the actual problem, and we're trying to make noise and actually act like we're solving problems, and we're not. So I just wanted to get your insight on that and see what you think about these issues, because they seem to be more prevalent in academia than they are anywhere else almost. I don't know.
Yeah, I think they are. I think they begin in academia. I agree with you. I mean, I think that there's, as I said, there's an overreaction to the problem.
Yep.
And generally the pendulum swings and then swings back.
Right.
So my advice is be patient.
Yeah, that's what I'm hoping for.
I mean, you're not going to get Ryerson's name back probably,
No,
but
I mean, I don't think so.
but all of the intense focus on the creation of all sorts of, of structures
Hmm.
to try and address the problem, that's going to wane.
Yeah.
And you know, in the process of all of this, the solution will appear. You know, when could be a long time away.
Yeah.
But it will appear, I hope. I mean, in a democratic society, the goal is to make that problem go away. That problem should not exist.
That's the hope, I guess.
That's the hope.
Yeah.
That's the hope. Yeah.
So I'm gonna ask you one last question, and I guess we can wrap things up. And this one last question might be, I don't know, it might be easy for you to answer, it might not be. What do you think has been your, I guess, life's purpose? If you were to think about it and summarize it, what is it that you hope you have accomplished? What did you set out to accomplish? Do you think you've actually, I don't know, made a dent in that sort of idea that you had for yourself when you first started this process of yours, let's say 50, 60 years ago?
Wow. You don't like asking easy questions, do you?
No, I told you I can get the technical stuff from the textbooks. I want to hear from you. I care about you as a person. The ideas are all over the internet.
Yeah, I think you credit me with too much by asking if, well, or by suggesting that I somehow had a life's plan. I didn't have a life plan other than, you know, I was very active in amateur radio.
Mm-hmm.
So I loved electronics and I loved building things. And there was no question that I wanted to be an engineer. Did I want to go into academia as a professor? That actually didn't occur until the last year of my doctoral program. Because there were all sorts of other opportunities in industry at that time. I mean, wonderful opportunities in industry. Once I got into academia, did I have a goal? Well, yeah, I guess it evolved. You know, I saw that, I mean, I was in electronics already, and I saw that power electronics was a new and growing field. There was no academic, there were very few academic programs in power electronics at the time. There was one at Caltech that Dave Middlebrook had. There was one at Duke that Tom Wilson was running, but that was pretty much it. I mean, Shashi Dewan up in Toronto had his program, but you know, it was just a handful of us who were interested in the power electronics. And if you look at the conferences, I don't know if, I guess I didn't show you the timeline of the IEEE's power electronics and IEEE. Anyway,
was that in the Senate lecture? I think it might have been, actually. I remember seeing that. You showed the picture of the shack where you guys had the first.
Yeah. But I had a time, actually, a graph of a timeline showing all the conferences and the events.
I think you did. Anyway, I think you did show that. Okay. Yeah.
Okay, but back in the early 70s, late 60s, which is when, I mean, the late 60s is when, you know, power electronics began to have an identity of its own. And, you know, the first conferences were the Power Electronics Specialist Conferences, PESC. And, you know, the number of people who attended those conferences was like in double digits. They were held in random places, you know, like conference room in one of GE's facilities. It wasn't no big deal, right? Everybody knew one another. So it was a brand new field. And what I wanted to do was create a an academic program in it and create a research program in it. And I think I succeeded with both of those goals. And, you know, I feel satisfied that I made some contribution to the field and to my institution.
Last thing, I guess. What do you want to be remembered for? That's the last thing I'll ask you, and I'll let you go after this.
I want to be remembered by my former students as somebody who they liked.
All right, Professor, this was absolutely wonderful. Thank you so much for taking the time to do this.